Hi, welcome to this video about mean, median, mode, and range. And we're going to be we're going to start by doing a quick example of those, and then we're going to be looking at two different sets, and we're going to be making a comparison between them. So for the first one, we're looking at world population, and it says the populations in millions in 2000, that's the year, on each of the 6 inhabited continents were, so the 6 inhabited continents, so that doesn't count Antarctica, it's not inhabited. So 803, that's 803 million. 487 million. So this is like a rounded number. It's about 348 million. Whereas this one, 3,000 millions, so that would be like 3 billion, 686 million, and so on. So this is the numbers we have. We're going to be finding the mean, median, and mode, and then find the range of these populations. So to get started, go ahead and take these numbers and put them in order from least to greatest. And there's only 6 numbers here, so it won't take us very much time at all. And as I'm doing that, I'm noticing that I don't have any repeated numbers. So this data does not have a mode. So there's no mode here. So there's none. No mode. But we're going to find the mean and median. So to find the mean, I'm going to add these numbers, and then I'm going to divide by 6. And to find the median, I'm going to count into the middle. So why don't you pause this video and try that, and then come back and see what we have. So for the mean, when I added the 6 numbers up, I got 6,085. That'd be 6,085,000,000 divided by 6, which gives me about 1 billion on average. Well, that seems kind of strange since the 1 is only 31 million. Well, that's because this is really an outlier. It's so much bigger than all the other numbers. It's making the mean way higher than it should be because the mean is way over here. And that's too far. It's not even in the middle. The median is a better measure of center. It's 600 million, which would put the median, of course, always in the middle, which is a better representation of the average in this case, and there's no mode to compare it with. Then we're finding the range. Well, the range is really high. Well, that's because this data really is a very far range. The min and max are kind of both outliers in comparison to what we have of the 4 middle continents, which are much closer together. So there we go. We found the different measures of center and then the one measure of variability. That's a good practice. Now let's look at where we have to compare 2 data sets. So what we're going to do is we're going to compare you and your friend's quiz scores. So you and your friend are having a competition on your math quizzes. I'm assuming these math quizzes are out of 20 points, and these are the scores you've gotten. So there's 5 scores for each of you, and they're listed. So one of the first things we need to do is go and put the scores, so in least to greatest. So I'm going to put your scores in order from least to greatest. And again, there's only 5 numbers, so it won't take very long. 17, 18, 19. So I have 15, 16, 17, 18, 19. Look at that, right in a row. And your friend's scores, we'll put those in order from least to greatest. 12, that was pretty low. 13, but then a 17 and 2 20s. Okay, so as we compare these so far, in your data, nothing's repeated, whereas in your friend's data, they have 20 repeated here, so they have a mode. So what we're going to do is we're going to divide this here section in 2 parts so we can find the mean, median, mode for both data sets. Okay, so, I need to put these numbers in order back. I realized I changed screens and it's gone, so 15. As you're doing that, why don't you add these numbers? And then we're going to divide them by 5. And so when I added them, I got 85, and divided by 5 is 17. And the median here, 1, 2, 3, as I count in 2.5, 2.5, the middle number 17. Well, the mean and median are the exact same number, and that's because this data is evenly distributed, it's symmetrical, and so everything is only 1 number apart. So the mean and median are going to be the same, and there's no mode. So this is very consistent data. Well, not consistent, but it's evenly spread out. So for your friend, let's put those numbers in order from least to greatest. They had a greater range, right? Your friend went from 12 and then 17 and 20 and 20 all the way up to 20. So they had a range of 8 points in comparison to 4 points. So their range is double what your range is. So they have more variability because their numbers are further apart. So let's find the mean. So when I add their numbers up, even though they have these higher scores on the end, because their 12 and 13 were so low, their sum is only 82. So 82 divided by 5 is an average of 16.4. So they have a slightly lower average. The median, however, is, since there's 5 numbers, I count in 2.5 and 2.5, and the middle number here. See when I circle that 17, how there's the same number of numbers on both sides? So the 17's in the middle. So you actually have the same median, and the mode is 20. So how would you compare the scores on who scores higher on their math test? Well, if you compare the scores, who scores higher, your friend has 2 perfect scores, which they started with. The medians are the same, but your average is slightly higher than your friend's. So in general, we would say that you are more consistent because you have and you tell that from the range, because your range is 4 and friend's range equals 8. So that means you have a more consistent data. The median is equal, but your average is higher. So depending on what you're looking for, I would have to say that you are doing a little bit better on these quizzes because your score, you're consistently getting a 17. You're closer to 17, and whereas your friend is like they have good days and bad days, and you're not really sure what their next score might be. So it seems like since your average is slightly higher, and you're a little more consistent, I think that you're doing a little bit better than your friend. So when we compare them, a comparison isn't always as simple as just black and white, boom, one's higher than the other. You have to kind of look at a lot of different parts, and then when you make your comparison, you want to compare 2 things. One, compare and see who's more consistent, who has greater variability. So you want to compare their variability, and then you want to compare their center. So something about the center, like who has a greater median, who has a greater mean, and that's how you're going to make a comparison. So you're using numbers and you're looking at variability and the measures of center. Thanks.